everyone. Thank you for having me, and thank you for having us. Super excited to be here because as a Japanese, being able to speak here at the KubeCon held in Japan the very first time, and it feels very special to me. And my name is Takeshi. I'm working for the company called Tetrate, where I'm working on Envoy Proxy as one of the maintainers, but also I'm working on this very project, Envoy AI Gateway, with Dan from Bloomberg. Dan, do you want to introduce yourself?
Yeah, my name is Dan. It's also my first time here and the first time talking about this project. Super excited. I lead the inference platform team at Bloomberg and the co-founder of Kserve and Envoy AI Gateway project.
Cool. So I think without much ado, let's get started. But I think Envoy AI Gateway project is pretty new. I think it was announced like last year's KubeCon NA North America, so it's less than 1 year old. So I think it is a very good idea to give some very generic introduction to this project in case anyone don't know anything about this project. So I think as the name suggests, it is relevant to Envoy Proxy, of course. It is under Envoy Proxy organization, and it is sub-project, I would say. It's similar to Envoy Gateway project. And as the name suggests, again, it is trying to solve some AI-related problems at the network proxy layers. So that is the main goal of this Envoy AI Gateway project. But also, not only just solving these problems in this project, but also we wanted to just give back to Envoy Proxy core so that we could because Envoy is so important in cloud native world, everyone is using it. So giving back to the community so that we could foster and advance Envoy project as a whole. So that is the very generic introduction to this Envoy AI Gateway project. So I'm gonna hand it over to Dan for goals, whatever.
Yeah, so first let's step back a little bit and then talk about why we created this AI Gateway project, right? So we have been a traditional API gateway to run predictive inference for many years and running on production. So how is GenAI traffic different? What are the challenges to manage GenAI traffic that's via traditional API gateways? So first of all, GenAI, the models are significantly larger, so it requires resource intensive to run these models at massive scale. So it demands much higher resource consumption on GPUs and substantial inference cost, which demands the gateway be able to meticulously manage these doing the resource management, inference optimizations at the gateway level. With the demand and resource demand and the cost, resource and the cost demand, rate limiting is an essential feature to be able to prevent abuse and ensure the fair usage policy across many different applications. So unlike the quick inference for traditional predictive inference, GenAI response can take several seconds or even minutes to generate the output, especially for complex prompt or even PDFs, images. It definitely requires a special handling, a different timeout strategy or asynchronous handlings, which we have tested. Some of the Python-based gateway was not able to handle the scale and the concurrency. In order to improve the user interactions, since this takes long to process, so it's essential for Gateway to be able to support server-side events, to be able to deliver real-time partial data without buffering, right? These generated data output can also be harmful, biased, or violates your safety guidelines. So real-time content moderation, PI data detection, filtering, input and output filtering are essential to do at the gateway level to ensure the responsible AI usage before content reaches to your end user. Obviously, all these GenAI agents applications want to leverage the various LM models from diverse providers. So Gateway needs to be able to deliver, be able to handle this talking to various different area models, and handles API, key management, cloud authentication to be able to access these model providers, and to normalize all these interactions for a variety of like model endpoints. As the Gen AI workload grow and to bridge these the gaps with traditional API gateway, so clearly there's a need to emerge for a specialized AI gateway that could handle multiple demands, unique demands of the Gen AI traffic. For like a model hosting, if you're hosting model itself, or like inference routing. So obviously we would want to build all this from scratch. Right, we want to ensure, in the sense, the nice thing in CNCF is we can make sure all the projects is composable, and you can build on top. So we really want to find like a strong foundation to build on top of. Envoy Proxy is an open source edge and like a service process designed for running in a cloud native environment. So it provides a strong and battle-tested foundation, and its high performance, extensibility, and a rich set of features make it really ideal for us to build building these features on top. For example, body transformations, because of these various model providers has different APIs, as well as to handle like advanced load balancing, intelligent routing, as well as the observability capability, building all these capabilities on top. It becomes much easier. So yeah, we have really like focused on like extending Envoy's this filter chain mechanism to be able to incorporate like AI-specific features, which moves really beyond the traditional API gateway can handle. And next, I will hand over to Takeshi to talk about the Envoy AI Gateway's features and architecture.
Yep. So this is a diagram like conceptually explaining how it's working, how it's interacting with like other components in the infrastructure. Like as you see, we have GenAI app, GenAI agent, and on the other hand, on the bottom, you see self-hosted models and the cloud models. So, and Envoy AI Gateway is sitting between these two components, like trying to have the centralized place where we could solve like connectivity between GenAI and the self-hosted models, as well as trying to like have safety features in place, trying to solve like have the central place like this. So this is very generic idea of how it's working with other components in infrastructure. And so we have quite a few key features in the Envoy AI Gateway project that makes like this project special or like unique compared to other proxies. One of the things is that unified API. So as we see, like in the last few years are crazy. We see so many AI services coming into the market. We want to utilize them, but the problem is that it is a good thing. But on the other hand, you see like on the downstream client or application perspective, if you want to use different models hosted on the different providers, you have to switch the like maybe SDK, but also we have to switch credentials to access that API. So we wanted to solve that problem at the network proxy layer, like trying to like allowing downstream clients to use OpenAI SDK to access any models in any different providers. That is what we call unified API. And to achieve that, we have implemented request-response transformation to mitigate the difference between or among multiple AI providers. That is the main feature of Envoy AI Gateway. And the next one is pretty unique to AI. So we all know a traditional rate limit, right? And it is where like cost of request is binary, like if a request is made or not. That is the static information that is available to proxy. But on the other hand, we have some new concept called token usage, which basically explains or calculates the result of number, like how much computation a request costs on the backend side. So it is very natural for platform engineers to want to do rate limit based on that usage information. But the difficulty here is that token usage information is only available on the response path, because that is how the token usage is the number, computation we needed to generate the response. So in order to do that rate limit based on that information, we have to make the change to Envoy Proxy core so that it will be response content aware rate limiting. So that is the key feature we have. And the next one is observability, which is somewhat relevant to token usage. But we also have LLM-specific stats. For example, we have token per second metrics, which basically is about how efficient a LLM backend is. And these stats are available and built-in feature in Envoy AI Gateway. And the next one and last one is pretty unique. Cross-origin or cross-provider fallbacks. It is different from the traditional fallbacks because, as I said, we have unified API. So in the retry, we have to modify the response request format depending on the retry target. So we have that fallback capability in the Envoy AI Gateway project. So now I've explained how the features and goals or whatever, but now I think it is time to explain how it works part. And so as the name suggests, Envoy AI Gateway is built on top of Envoy Gateway. So we have two control planes. We have own control plane as well as Envoy Gateway has also control plane. And also we have AI-specific CLDs. So what our control plane does is that it will translate AI-specific CLDs into Envoy Gateway or Gateway API resources. Then they will be consumed by Envoy Gateway. But in addition, our control plane will modify Envoy role configurations through Envoy Gateway extension server protocol to do the kind of fine-tuning of the configuration. And lastly, we will insert AI Gateway external processor, which is the extension mechanism of Envoy Proxy, which we call also ext-proc. And on the data plane side, we of course using Envoy Proxy as a pod deployed and managed by Envoy Gateway. Plus, as I explained, we are using ext-proc sidecar at the data plane side. So here's the diagram of what I explained about the control plane. So as you see, we have two circles. Pink ones is the Envoy Gateway controller, and on the top right you see AI Gateway resources, and then they will be consumed by our controller. Then they are translated into Envoy Gateway resources. Then in turn, lastly, they will be consumed by Envoy Gateway controller, and then finally they will be translated into raw Envoy configuration. But before the control plane finalizes the configuration, it will talk to Envoy Gateway, AI Gateway to do some fine-tuning. And this is the explanation for data plane side, how a request is processed by Envoy AI Gateway. So as you see, client is using OpenAI SDK. So it's making a request to Envoy Proxy. Then first, Envoy Proxy will check a request should be allowed or not, depending on the token consumption before. And then if it is OK, it will reach external processor. Then it will extract model field from the request body, which is a crazy thing, by the way. Also, it will do the routing decision and then send them back to Envoy Proxy. And then it will enter some fallback retry loop. And at the beginning, Envoy will select some upstream or endpoint, which is where Envoy will know which backend or AI provider will talk to. Then with that information, AI Gateway, it's running out of time. OK, I think I'm going to skip that. OK, this is how request is processed. Yep.
So next, I'm going to dive a little deep dive to the AI-specific resources. Takeshi just talked about So first I'm showing the AI service backend and the backend security policy, where you define the specific model provider API schema, and the security policy is used to defining the credentials to access cloud providers. And so this allows us to have like a centralized cloud credential management to where you can have a unified and a single place to store all these cloud credentials without distributing all these API keys or like credential to your end user applications. So this really improved the security and the maintainability. To prevent scattering all these critical credentials. In addition to the cloud credential authentication mechanism, so Envoy AI Gateway also supports OIDC federations, where if you have your own identity provider, OIDC provider, so Envoy Gateway will be able to allow you to use your identity to exchange to the cloud credentials. It also handles automatic credential rotations, so this is really critical to ensure your system reliability to avoid outages like your credentials expired. This really reduce a lot of the burdens like manual operation or to renew these credentials manually for the team and hence improve the reliability. So next I'm talking about the most important API resource called AI Gateway route. So it sounds very familiar. So you can think of it as AI native equivalent of HTTP route, which is from the Gateway API. So why yet another CRD, right? You might have the question. Because here, as you can see, this GenAI traffic has its own unique characteristics where like you need to define the token relimiting and to handle the load balancing and fallback to move a little bit beyond the traditional where like it just requires AI specific like body transformation, and it also requires a unified API to handle the diverse model providers. Which is where it's a little different from the traditional like HTTP routing. So this shows a case where you can like have like a more advanced load balancing across different regions for the same providers, or even cross different model providers, where you can do load balancing if you are, especially like for GenAI, I know a lot of people are running like resource constraints where like a single provider may not have say enough capacity to handle all the traffic you have, so you may need to spill over to the other cloud providers when you're like a primary provider doesn't have enough resource. Just be careful. Sometimes there are subtle difference for this model features supported by different model providers. So when you do cross load balancing, you may not, certain features may exist on one provider, not the other. So just be cautious, like when you define these rules, make sure the models are compatible between like these multiple providers. And another important feature it's to ensure your system resilience is critical for GenAI students to maintain the high availability and reliability. So to achieve the target S0 you require for your critical GenAI application, I think the resilience is the most important to stay like a zero downtime, right? So whereas I know there is a lot of use cases where like downtimes are not acceptable. So here, like similar to the load balancing, but here, like you can see that you can have the same model, you can back up by multiple backends. And so here, like we have the backends from Azure and OpenAI. So yes, they have like different priorities, right? So your preferred model provider in this example is Azure OpenAI, where it hosts the GPT models, and your backup like model provider is OpenAI. Right, so they may not be able to like support the SEO you want, but in case your primary model provider is not available or overloaded, so you can fall back to the on-demand. Sometimes they support this on-demand model endpoints. So similarly, like you have to ensure the models are compatible between these model providers when you like define these rules. So last not at least, so it's the Takeshi mentioned the cost-based rate limiting. So this is where we extended Envoy, right? Traditional Envoys, the rate limiting is based on request. But now, things like token, a lot of the ARM providers is based on the token-based billings, right? So it's important you have this granular cost control for your ARM workload, right? So in the Envoy Gateway, we offer this provides this flexible configuration where you can define your cost formulas, where the so since here the cost is not the number of API requests, but it's the cost of input and output tokens, right? So you can, where it gives you the flexibility to define how these different token types, input and output, can contribute to the final cost. For example, the cached token you can reduce your inference cost by using cached tokens, right? Where you have repeated all these common requests where it can be cached. So this is a common methods you can use to cut down your inference cost. So here example, you can see here we have defined a premium user tier. So where you can use up to 500,000 tokens per minute, right? So this is the request is really a cost, not the number traditionally the number of requests. So next.
We are running out of time.
Oh. Okay,
Unfortunately, I think we cannot show it right now, maybe.
Let's do a quick 3 minutes. So I think I prefer that, but live demo, but I think we can just quickly show it. So here, I just want to show the, so we have defined the AI gateway routes, where the one route is routing to the Azure AI OpenAI, and then the other route to the OpenAI. So we have another fallback rules where you can say your primary route is from Azure OpenAI, and the backup is OpenAI. So you can see from this notebook, we have examples where you can call the tools and get the current what's the current weather, and then you can forecast the next day, the next end days of the weather. So you can see, so this example showing you access the Azure OpenAI for the GPT model, right? So it gives you the response back, where you tell the model where you are, and then it'll give you back the wizards. So you can see here, it's routed to the, I'm just showing the path here because there's sensitivity of the host names. So you can see here, yeah, it routes to and this example is actually using the fallback rules where the primary is the OpenAI, right? So you can get the similar response back. The general output, I think it might be the same. So it's the same calling the tools and give back. So you can see here the path is actually sending to the OpenAI. And now I'm going to just simulate if your primary model provider is not available, I just added the host name to be a bad host, right? So this is and then so now your primary model provider will be down, right? So let's check back. So the Envoy allows you to dynamically pushing these configurations, and then takes very quick to propagate all the configurations. And now let's see if you will expect errors or not. Right, so I can see the response back. Yeah.
It's cool.
Here, yeah, okay, you got the response back. So let's check, right? Where it's route to, right? So since your primary is down, so you can see the path here is actually falls back to the Azure OpenAI model provider now. Same, so it just keeps going, generate the same tools, calls. And then now, I'm going to bring the primary provider back. So I just change back the right host. OK, the configuration is propagated. Let's see if it falls back to your primary model provider now. So yeah, here you get the response back, right? So let's check where is the route to right now. You can check the endpoint path pretty much the same way. So now, yeah, see? So now it falls back because your primary model back is come online. So
cool.
Yeah. Cool. What is this? I have no idea.
All right, we are running out of time, so
Yeah,
thank you for coming. I hope you guys enjoyed our talk. Yep, thank you.
We have one last slide, community question. Okay, so this is you have
Yeah, that's it.
questions? That's it.
We don't have any times to take any question, right? I think.
Fine, if any questions, I'm happy to answer.
Yeah. Okay, cool. Feel free to reach to us.
Yeah, feel free to catch us offline.
Yep, yep.
Thank you, everyone.
Thank you, everyone. Yep.